Hello engineers, welcome to the course on CATIA. This course is actually a basic course on CATIA. Yes, we have an advanced version of this course as well. This course is being designed for engineering students, passed out freshers as well as industrial professionals who are actually looking forward to develop their career in engineering design field. As we are aware that India is actually recognized as a manufacturing hub at the world level. Most of the product of many industries are being manufactured in India but not designed in India. To change this reputation, to make India being recognized as a design hub as well, we have designed this course. This is just a first step towards that. And CATIA is one of the solution. CATIA is one of the tool which is being most widely used by the industries for their design problems. Before going to start CATIA, first we will have to understand what exactly CAD, CAM and CAE is. Let us have an introduction to CAD, CAM and CAE. CAD, CAM and CAE are basically the technologies used to design a particular product. First comes CAD. CAD is referred as computer aided designing or computer aided drafting. CAD is basically used to create a design or drafting of a particular product. CAD tools are capable of creating the model as well as generating or creating the drafting for a particular product. Next comes CAM, computer aided manufacturing. Computer and aided manufacturing tools are used as a manufacturing support in the industries. Whatever CAD model we have nowadays, we have higher end machines are available in the industries. Those machines require less amount of instructions from human. They actually works on programs. To generate those programs, we can use computer aided manufacturing tools. To generate the program, the respective CAD model of the product can be utilized and some added information regarding machine parameters is required to be fed, and you can easily generate the program, copy it to the machine, and machine will follow the generated path as per the instructions. Next is computer aided engineering. Computer aided engineering or CAE. CAE tools are basically used for the analysis part in the design. When you have created a model or a design, directly industries never go for manufacturing of that particular product. They first analyze that as per the requirements. They perform all the analysis for checking the possibilities of that particular product, whether that particular product will be able to work in the conditions required or not. This these CAE tools helps us in reducing much cost before manufacturing of any particular product. After understanding CAD, CAM, and CAE, one question is still there in the mind, that how exactly it has started, from where this evolution of computer aided things came, how we can reduce that much of cost, that much of time by using the computers. Who actually invented this? Who actually thought about it, or from where it has started? So let me clear you that it actually has been started from the drafting, not from the modeling. Yes, we have many dedicated tools or many higher end tools for the modeling, which are basically focused on creating the models, creating the manufacturing drawings, creating the assemblies, and we also are interested in that. But the evolution of computer has came from the drafting. First, the tools were developed for creating the drafting. As you can see in the images, the engineers are performing the drafting work. Now you can see that the drafting sheets are too larger in size, and this was the way of drafting before the evolution of computer comes into picture. And it used to take too much time just to generate or just to create a drafting of a single part or a single machine. After the manual drafting, when the evolution of computer comes into picture, people started using or creating the drafting using computers. One of the most popular tool for the drafting is AutoCAD, as you already know. Later on, more and more tools were developed, and the evaluation shifted from drafting to creating the models, then assemblies, then generated drafting as well. Next, let us understand what exactly CAD tools does. Why industries are actually preferring CAD tools for their design work. Why industries are utilizing these CAD tools. What exactly can be done using the CAD tools rather than creating the model. We can utilize CAD tools for converting 2D drawings into 3D drawings or 3D models, I would say. We can even utilize the CAD tools for generating 2D drawings out of our 3D models. It can be used for creating assemblies as well. The most important part or the most important feature of any CAD tool is easy modification. If you have any revision comes for your model, then you don't need to create the model again. The CAD tools allows you to modify it very easily, and the revision can be created within minutes. Relations between parts. Say in your particular design of a machine or any assembly, you are using nut and bolts. So you can provide the relation between nut and bolt so that if you modify parameter of any of the part, say you are modifying the parameter for the nut, then the parameter for the respective bolt will automatically be updated. But yes, first you will need to define that relation between those two parts, then and then only you will be able to use this particular feature, which will make your design modification easy, and it will save your time as well. Using CAD tools, you can go for analyzing the parts as well. Say you have created multiple parts, you have created the assembly as well, but the due to some changes in parameter, you have some clashes in your assembly. Then at the CAD modeling and assembly level only you will be able to analyze it, whether there is any clash in the assembly. If there is any, then you can modify the dimensions or parameters of that particular part, and you can resolve it. You don't need to go to the manufacturing stage and then realize that there was clashes in the parts. Yes, we can go for the parameters as well. I have created the part, I can easily calculate the CG, calculate the volume, weight, inertia of the part using some clicks on my software. Data storage is very easy. I have to store multiple drawings. I have, say, in my particular assembly I have 1,000 parts. Then using the computer applications I can easily store the data. I can easily rename it. I can easily send it to anyone if required. And as we discussed, further modifications and all these things are very easy due to involving the computer applications in that. I can go for the PLM as well. PLM is actually product life cycle management. So if I am using any uh, PLM interface, then I can maintain the product life cycle as well. It plays major roles in product development and many more. So we have many applications of CAD, CAM and CAE tools in terms of maintaining the data, in terms of generating the parameters, in terms of maintaining the relationship between parts, in terms of further modifications, assemblies, which has actually made our work easier as compared to the previous our manual work. We can easily store the data, we can easily convert the data, we can easily share the data whenever required. Next is classification of CAD tools. Now focus that I have mentioned CAD as CADD because here I am referring CAD tools as computer aided designing and drafting tools. Later on I will classify it in computer aided designing tools separately and computer aided drafting tools separately. First we will have computer aided designing and drafting, and we will classify computer aided engineering tools separately. In computer aided designing and drafting, we have 2D CAD tools. Now when I am saying 2D CAD tools, so here CAD is actually referring as computer aided drafting. For 2D CAD we have AutoCAD, ZWCAD, KDN and many more tools available which industries are using as per their own convenience. Similarly for 3D CAD, here now CAD is referred as computer aided designing. We have many tools like Creo, or the previous version of Creo is actually referred as ProE or ProE Wildfire, you may know. CATIA, which we will see in this training. SolidWorks is one of the tool. UGNX, or some will call it as Unigraphics. Solid Edge is one of them. Inventor, Parasolid, and many more tools are available. Industries are preferring these tools as per their requirement, as per their convenience, as per availability of the software, or as per their use of that particular software. Next comes CAE tools. CAE tools we have ANSYS, Hypermesh, Console, MATLAB, Nastran, and again many more. Each tool will have their own applications. Each tool will have their own specialization, due to which industries are preferring them over other tools. Next, let us understand some basic information about CAD tools. We have discussed some 2D CAD tools, some 3D CAD tools, as well as CAE tools. But there is something common in all the 3D CAD tools, and one of the 3D CAD tool we will complete in this training. There is always some guidelines on which a particular product is being developed. Our 3D CAD tools are also a product, and these products are actually being created on some guidelines or by following some rules, by following some technologies. One of them is feature based modeling. All of the CAD tool actually follows feature based modeling technique. Next comes parametric modeling. As we had discussed that we have to modify some of the parameters to update the product or update the model. We have to modify some of the parameters to go for the revision. So yes, we will be using the parameters, and this parametric modeling thing will actually make our work very easier. Third thing is associativity features. Every CAD tool actually maintains the associativity feature, or I will say it has a property of maintaining the associativity. About these three things, we will have a detailed discussion, starting with feature based modeling. As you can see, I have shown uh, modeling steps for a connecting road. You can see starting from left, there are some steps while creating this connecting rod. First, in the first step, one base is created. In the next step, uh, one some material is actually added on side. Then in the next step, the same material is added on the other side. Then one hole is created, then another hole is created, then fillets are applied, then finally the uh, hole on the side is created. So these are actually steps. And whenever you create a model using a CAD tool, you have to follow the steps, because using a single click you can never create any CAD model. When you want to create a CAD model, you have to follow the steps. You have to divide the modeling of that particular CAD model into some steps, and those steps are actually, in terms of software, is called as a feature. So when you create a feature, then another feature, then another feature, then another feature, and you develop your model, that is your feature based modeling, or we can call it as step by step modeling. So what we do is we build a feature, that too simple feature, at a time. Then each new feature can have the reference of previous one. Like in the example of connecting road, I have created one pad first, then using the reference of that first pad I can create another pad. Then using the reference of those two I can create another pad. Then using the reference of those two I can create the whole, and I can uh, proceed further process. This is your feature based modeling. Whenever you want to create any model, first you will have to divide that. Just to understand, when we try to create any assembly in CAD model, in CAD tools, what exactly we do? We divide our assembly into some parts, because any machine or any assembly directly cannot be created. So similarly, when we want to create a part, then we divide that into some features or into some steps. So that is your feature based modeling. Next comes parametric modeling. As I told you that we will have to use the parameters. Parameters are basically the dimensions that we provide whenever we go for the modeling. Say I have created one sketch. To that sketch, I am providing some dimensions. If a rectangle is there, then I will be providing length and width. Those two, length and width, are actually your parameters in terms of the CAD tools. Parametric modeling says that whatever the shape of your model or size of your model you want to control or maintain, you have to do it with the parameters. When you want further modifications, then you don't need to shift the feature. What you have to do is you have to change the parameter. So as I told you, model geometry is actually controlled by dimensions and parameters. When a dimension value is modified, then relevant geometry is automatically updated. Just have a look at the image over here. In the first image, some parameters are given. So height is given 18.5, the hole dia is 5, and the position of hole from the top is given as 8 mm. I will consider it in mm for now. Now, when I'm modifying one parameter, the parameter which is length to 25, from 18.5 to 25, then you can see the model is updated, and as I have given this 8 from the top face, now the top face is available at height of 25 mm, so it is maintaining that height of 8 mm from the top. Doesn't matter where the top end is, it will maintain always 8 mm from that. Okay, this is actually your parametric modeling. I have given some reference, it will always maintain that parameter from that reference only. Similarly, in the third case, the height from the top is changed to 12 mm, and the diameter is also changed to 10 mm from 5 mm. So you can see it is maintaining that height from the top only. It doesn't matter what the value is. If you have given the reference as top face, it will always maintain it from the top face. The same thing is actually called as parent child relationship. The features referenced during creation become parents. So when I had created this hole over here, then the previous feature, which is actually the cylinder and the faces of cylinder, has become parent for this particular hole. If parent feature changes like it changed in the second case, the child feature predictably changes accordingly. So the level of this whole automatically changes with the parent feature change. Next is your associativity feature. We had discussed that whenever we create any CAD model, then we use that CAD model for generating the manufacturing drawing as well, which is we call it as drafting. We can even use the same CAD model for the assembly as well. So when we do all these things, we have a single part. For that particular part, I have generated the drafting as well, and I have utilized that part in the assembly as well. Now if any modification comes into picture, say I have a revision of a part. So for an example, you can consider this particular part, this one road available, the same road I have used for the assembly, and I have generated the drafting for that as well. Now say the revision is there for the road, I want to change the dimension for the road. Now do I need to change the dimension of road in all the environments like part design, assembly, as well as drafting? The answer is no. I don't need to change the dimensions in all the environments. The software itself maintains the associativity property that if I will change the dimension of road in any of the environment, then it will automatically update the same dimensions in all the remaining environments. So if I open the part design environment and make any changes in the length of the road or diameter of the road or any other thing, then it will automatically be updated in the assembly, and it will automatically be updated in the drafting as well, which has actually made our work easier, and our time is also saved. So this was all about the CAD CAM CAE tools as well as the properties these tools follow. What are the applications where we can utilize, or what are the applications which for which industries are actually using or preferring these tools? For sure, we will be using all these things. We will be going through all these things during our training on CATIA. In the next session, we will have an introduction about CATIA, and we will have a look at the graphical user interface of CATIA in the next session. Thank you.